Today we'll discuss some more problems of diode circuits from analog electronics. If you see, we have nearly 15 to 20 questions today. These are the questions which appeared in previous year examinations. This is appeared in RRB SSC, and this is some a diode circuit which appeared in BPSC Polytechnic Lecturer. This is in RRB JE examination, like this. These are the circuits that we need to solve today for better practice for the GATE and engineering service examination. These are helpful for ISRO, DRDO, BSNL, and other public service units also. Okay. Now let us see the solutions for all these problems. So look at the first question. Assume that D1 and D2 in figure are the ideal diodes. The value of current I is. So he's asking us to find out the value of the current through D2 diode. This is the diode D2. This is the diode D1. He's asking us to find out the current value through D2. So if you observe circuit carefully, 5 ampere circuit, 5 ampere ammeter. This is nothing but a 5 ampere current source. Okay, it is heading towards the upward direction. Means the current is flowing in this direction. So the current will flow in this direction. It will divide in D1 branch and this resistor, and afterwards it has to enter the D2. But the current here cannot go downward direction because it is forcing the diode D2 to be off. It is forcing the diode to be in reverse bias direction. So diode D2 doesn't conduct here. In this circuit, D2 is reverse biased, so it is off. D1 is on. Diode D1 is forward biased and it is conducting state. It is in the conduction state. Current flows. So if you read out the circuit, it will be like this. This is a 5 ampere current source, and this, the diode D1 acts like a short circuit and D2 acts like an open circuit. And these are the resistors, 4 kilo ohm and 6 kilo ohm. So the current flowing through D2 is 0. So the answer is option C. So here, if you look at the next question, for the circuit shown figure below, the voltage V0 is. So he's asking us to find out the voltage V0 here in this particular branch. But if you read out the circuit, here, this is the 4 volt input voltage, and this is a 2 ohm resistor. And there is a diode here. There is a 2 ohm resistor. This is again a 2 ohm resistor with 2 volts here. 2 volts in the reverse direction. So now he's asking us to find out the voltage here, V0. But we need to observe that this particular branch, this whole branch, here diode is ideal. So if diode conducts, it will act like a short circuit. So you need to remove this whole branch and find out the equivalent resistance and equivalent voltage like Thevenin's. So by applying Thevenin's theorem here, you need to find out the V Thevenin's and R Thevenin's. Hence, this is the branch that you are supposed to remove. This branch I am removing here now because this is the branch across which I need to find out the output voltage. Okay, so I need to find out V Thevenin's and R Thevenin's. What will be the V Thevenin's? The current flows in this direction. The current is flowing in this direction. Calculate the current. Current I is equals to 4 plus 2 volts divided by 2 plus 2, that is 4 ohms. So the answer is 1.5 amps. 1.5 amps is the current that is flowing. So what is the voltage across these terminals? V Thevenin's will be 4 volts minus 2 into 1.5, that is equals to 1 volt. Here in this branch, if you calculate 4 volts, and the drop here is 3 volts. So 4 minus 3, it will be 1 volt. R Thevenin's you need to find out by replacing the voltage sources with short circuits. So if you observe in that way, the 2 ohms and 2 ohms will come in parallel. So R Thevenin's will be equal to 1 ohm. So we have got the V Thevenin's as well as R Thevenin's. Now you read out the circuit. If you read out the circuit, this is V Thevenin's, that is 1 volt. This is R Thevenin's, that is 1 ohm. And connect the branch, that is diode, and this 2 ohm resistor. Now you find out the current in this circuit. If you find out the current in this circuit, I is equals to 1 divided by 3. Because the diode doesn't have any voltage drop as well as resistance, because the diode is ideal. So this is the current. Now he's asking us to find out the voltage across this 2 ohm resistor. So the voltage across the 2 ohm resistor, that is V naught, is equals to minus. Why minus? Because the current direction and the voltage polarity both are opposite in direction. Okay, so it is minus 1.3 multiplied by 2, that is minus 0.67 volts. This is the answer. So here the answer is option D, none of the above. Now we'll see the next problem. This question is asked in RRB. Okay, RRBG. The gun diode is made up of, it is gallium arsenide. Gun diode is made up of gallium arsenide. Sometimes they use the material germanium and cadmium telluride. Cadmium telluride also is used, and also indium arsenic, indium antimonide. This is indium antimonide. Indium antimonide. These are all the materials which are used for making gun diode. This is cadmium telluride. So anything is fine. All these are the answers. Okay. So in the given options, the answer is gallium arsenide. We'll see the next problem. A dash is the electronic circuit that changes the DC level of the signal to the desired level without changing the shape of the applied signal. It is nothing but a clamper circuit. Okay. We have seen even in the previous videos the function of the clamper. This is the input voltage, and this input voltage will be either shifted to the positive side or negative side depending on the clamper circuit. If you give this input voltage to a positive clamper, this is the positive clamper, this is a capacitor, the diode is facing upwards, and a resistor RL. Then the output is the signal without changing its shape shifted to the positive direction, shifted to the positive DC levels. If the same signal is given to a negative clamper, that is a diode is facing in the downward direction. With the direction of the diode facing, you can identify easily what type of clamper it is. And the output signal will be like this. This is the zero level, and the waveform will shift towards the negative bias. This is the negative clamper. Okay. So, an electronic circuit that changes the DC level of the signal without changing its shape is nothing but a clamper. Answer is option B. Now, if you see the next question, the Zener diode in the circuit has a reverse breakdown voltage of 10 volts. The power dissipation in RS, that is a series resistance, would be. Now let's find out. This is a Zener circuit, Zener diode, and a load resistance RL. Input voltage is 30 volts. Series resistance is 100 ohms. So he has given the load current IL is 50 milliamps. Now we'll find out. He's asking us to find out the power dissipation through RS. That is series resistance. Means first we have to find out the series current IS. So series current IS is equals to input voltage minus Zener potential. This is Vz. So input voltage minus Vz divided by 100 ohms. What is the input voltage? 30. Zener voltage? Zener voltage is 10 volts. It is given in the question. Vz, breakdown voltage of 10 volts divided by 100, which is equals to 0.2 amps. Now the power in the series resistance is equals to I square S into Rs. That is 0.2 whole square into 100, which is equals to 4 watts. So the answer is option A. Like the video, share the video, and subscribe to the channel for better content and more videos. We'll see the next question. What is the output voltage V naught, that is here? Output voltage V naught for the circuit shown below, assuming the diode is ideal. He is telling the diode is ideal diode. Okay, now let's see this question. Here, you have to break this circuit into two parts. Okay, And this is the node. This is the node where from where you have to apply the nodal analysis, because this is V naught. So you just assume the current, if you apply KVL here, KCL here, nodal analysis is based on KCL. The current, all the current leaving a node is equals to 0. That is the concept of KCL, nodal analysis. So assume this is current I1 and this is current I2. So I1 plus I2 must be equal to 0. Here in this case, what about the diode? What is the state of the diode? Diode D is forward biased or reverse biased. So let's find out whether diode is forward biased or reverse biased. If you observe carefully, the diode P type is connected to minus 3 volt. This is the diode. The diode P type is connected to minus 3 volt. And N type is almost connected to minus 4 volt. Because the plus 5 volts and 1 volt, if you subtract, it is minus 4 volt. So here, P type has the higher potential, N type has a lower potential. So diode is forward biased. So based on this, we will go further by applying nodal analysis. By applying nodal analysis, we get I1 plus I2 is equals to 0. Whereas I1 is equals to V naught minus, so V naught plus 5 minus 1 divided by 2 kilo ohms plus V naught plus 3 divided by 3 kilo ohm equal to 0. So if you solve this, V naught plus 4 divided by 2 kilo ohms is equals to minus of V naught plus 3 divided by 3 kilo ohms. So by solving this, we'll get an equation 5 V naught is equals to minus 18, whereas V naught is equals to minus 18 by 5 volts. So the answer is option A. Hope you understood this problem. We'll see the next question. So what is the value of the current I through the diode, ideal diode in the circuit? So he's asking the diode is ideal and what is the current flowing through the diode. See, if the diode is ideal, the diode acts like a short circuit. So this is 10 volts, 50 ohms, 5 ohms, and diode acts like a short circuit. Okay, so the current, whatever current comes here, it will not enter the 5 ohm resistor. It will directly pass through this short circuit. Okay, so the current I is equals to 10 divided by 50, which is equals to 200 milliamps. So the answer is option C. So what if, my question is, what if diode is practical, means diode is not ideal, but diode has a voltage drop, Vt is equals to 0.7 volts. What if? Let's solve the question again. This is 10 volts, this is 50 ohms, and this is 5 ohms. So in this case, you have to remove this diode. You have to remove this diode and find a voltage drop across it. You have to find a voltage drop here. So here the voltage drop, first we need to find out the current. Current is equals to I is equals to 10 divided by 50 plus 5. This is the current, that is 10 divided by 55. The voltage drop across the 5 ohm resistor is, will be, that is the voltage drop across the diode also. So 10 divided by 55 multiplied by 5, which is equals to 10 by 11. So approximately it is 0.9 volts. So 0.9 volts is the voltage drop across this resistor, 5 ohm resistor, 0.9 volt. So here in this case, diode needs only 0.7. So the voltage across the diode 0.9 is greater than 0.7. So diode is forward biased. Diode will be forward biased. Okay. So the diode is forward biased. So if you read out the circuit, considering that the diode is forward biased, here this is 10 volts, 50 ohms, 5 ohms, and here it is 0.7 volts. That is the voltage drop across the diode. So if you want to find out the current through the diode, then I D, current through the diode, is equals to IS, that is a series current that is coming here, minus the current flowing through 5 ohm resistor. Series current minus I, that is the current flowing through 5 ohm resistor. So ID, current through the diode, is equals to series current will be 10 minus 0.7 divided by 50 ohms, minus current through the 5 ohm resistor is 0.7 divided by 5 ohms, which will come approximately 0.046 amps, that is 46 milliamps. So that is the current if the diode is practical. 200 milliamps is the current if the diode is ideal. We'll see the next question. Find V naught for the given circuit. So this is the clamper circuit with positive bias. What kind of clamper is this? This is a positive clamper with a positive bias. Okay. Now let's see the circuit here. So when the input voltage contains the positive 10 volts and during the negative half cycle it is minus 20 volts. So during negative half cycle, the diode conducts, diode D conducts, and current flows in the circuit like this. During the negative half cycle, the current flows like this. It will be negative here, positive here. And this charges the capacitor to which volt, because the negative voltage is minus 20 volts, and additionally there is a 5 volt in addition. So the capacitor will be charged to 25 volts. So now, if you consider the output voltage after the capacitor is charged, it is capacitor voltage Vc plus Vin. Okay, I draw this in blue line. The capacitor voltage Vc plus Vin, that is the output voltage. Okay, V out is equals to the capacitor voltage Vc plus Vin. What is the capacitor voltage? It is 25 volts plus Vin. So if you redraw the circuit based on this, if you redraw the output waveform based on this, the output waveform will be like this. So V output minimum will be 25 minus 20, that is 5 volts. V output maximum is 25 plus 10, that is 35. So it will be fluctuating between 35 volts and 5 volts. 35 and 5 volts. This is the output waveform. So it's not just a positive clamper that shifts the waveform to the positive side, but also there is a positive bias. See, this positive bias of 5 volts pushes the waveform 5 volts away, further positive. So that is the function. See, if the same diagram is given like this, assume the circuit is given like this. The diode is facing downwards. Sorry, you can take the diode is facing upward only. This is a positive clamper, but given voltage is negative 5 volts. Okay, minus 5 volts. Then what will be the output waveform? The output waveform will look like this, somewhat look like this. This is the actual thing what we need, that is 30 volt and 0 volts. This is what exactly the positive clamper will do. But here, because of applied negative bias voltage, it will move 5 volts further down. What happens? Here, this becomes 25. This becomes 25 volt. And the waveform will end up with negative 5 volt, minus 5 volts. Hope you have understood this concept. Based on the applied bias voltage, the waveform will shift upwards and downwards. If no bias voltage is there, if there is no bias voltage, it is simply acting like a positive clamper, then it will be 30 volts and 0 volts. The output waveform will be fluctuating between 30 volts and 0 volts. If negative bias is applied, it will go further down. If positive bias is applied, it will move upside. So based on the bias voltages, the waveform will move further positive or further negative. So based on the diagram, you should be able to judge the output. We'll see the next question. Like the video, share the video, and subscribe to the channel for better content and more videos. If the cut-in voltage and the forward resistance of each diode, so cut-in voltage is 0.7 volts and forward resistance is 1 ohm. The current through 48 ohm resistor is. So if you see, the applied voltage is DC voltage. By the DC voltage terminal means polarity, you can easily tell that the D1 and D4. If you assume this is D2 and D3, D1 and D4 are forward biased here. D1 and D4 are forward biased. So current flows only in that direction through D1, 48 ohm resistor, D4, and back to the voltage. This is the way how the current flows. So find out the current I is equals to 8 divided by 8 minus 2 voltage drops will be there because two diodes are phased. Minus 0.7 minus 0.7 divided by 1 ohm plus 48 ohms plus 1 ohm. 1 ohm and 1 ohm are the diode resistances. So if you calculate this, it will be 6.6 divided by 50 ohms. So the current I is equals to 132 milliamps. So the answer is option A. Now let's see one more question. Assume diode D1 and D2 to be ideal diodes. So there is no voltage drop across the diodes. Which of the following statements are true? See, whenever this kind of questions are asked, you have to first find out which diode D has highest potential difference across it. So for D1, if you see minus 2 minus of minus 9, so it is 7 volts. For D2, if you observe, here it is 2 volts, here it is 9 volts. 2 volts minus of minus 9 volts, that is 11 volts. So which has got the highest potential difference? D2 has got the highest potential difference. So D2 will be forward biased first. D2 will be forward biased first. So if the D2 is forward biased, how the circuit look like? It will be like this. This is D1 minus 2 volts. This is D2, which acts like a closed switch, plus 2 volts. This is 10 kilo ohm resistor. Sorry, this is minus 9 volt. So D2 acts like a short circuit. So this entire 2 volts appear at this node. Now with this new voltage differences, what is the position of D1? D1 will be reverse biased because its negative terminal has the positive voltage 2 volts. Its positive P type is facing towards the negative volt, negative 2 volts. So D1 will be reverse biased. So this is off. D2 is on. This is the way how to analyze the circuit. So the answer is option D1 is off and D2 is on. That is option D. We'll see the next question. In the circuit shown in the figure, assume the diodes are ideal and ammeter is an average indicator meter with zero internal resistance. The ammeter reading is. So what is the ammeter reading means? What is the current flowing through the ammeter we need to find out. So during the positive half cycle, using the positive half cycle of input, what happens? This is sinusoidal voltage. D1 is forward biased. D1 is forward biased and current flows through D1. D2 will be reverse biased, that acts like an open switch. There is no current in that. So current flows in this direction. And what is the current value? The current value I will be V divided by 10 kilo ohms. What is V? 4 sine omega t divided by 10 kilo ohms. That is 0.4 sine omega t milliamps. That is the current flowing through the ammeter and diode D1. So during negative half cycles, what happens? This is minus and plus. Diode D2 acts like a closed switch and diode D1 acts like an open switch. So there is no current through the emitter here. There is no current through the emitter. So negative half cycles cannot be considered. So the current flows only during the positive half cycles through the emitter, like this. So this is nothing but a half wave rectifier output. The current peak value is 0.4 amperes. So for the half wave rectifier, the DC current, average current is equals to Im by pi. Here Im is 0.4 amps and pi. So what will be the answer? The answer is 0.4 by pi milliamps. This is the answer. We'll see the next question. The cut-in voltage V gamma and thermal voltage for the diode shown below are 0.498 and 2 millivolts. If the value of the resistance R is 20 ohms, the current flowing through the diode is. It's very simple. He's asking us to find out the current flowing in the circuit. I can be given by V minus. Here the cut-in voltage is given, that is V gamma, divided by resistance R. That is 5.5 volts minus 0.498 divided by resistance is given as 20 ohms. So the I is approximately 250 milliamps. So the answer is option B. Photodiodes and solar cells are normally operated in the quadrants. That is, photodiodes operate in quadrant 3, solar diodes operate in quadrant 4. So the answer is option A. Next question. This question is asked in DRDO 2009. The correct match between the following two columns is tunnel diode. Tunnel diode is used for microwave amplification because of its negative resistance characteristics. Tunnel diode has negative resistance characteristics, due to which it is heavily used in microwave amplifications. Whereas Zener diode, because of its voltage stability, stabilized voltage output, it is used in voltage regulation. Pin diode is used in photo detection because of its intrinsic nature in between. In pin diode, there is an intrinsic semiconductor in between, which conducts very heavily between P and N. So this helps the pin diode to generate the reverse current when it is exposed to the quantum energy, that is light energy. So pin diodes are basically used for photo detection. Schottky diodes, these are used in high speed switching. Means basically it is used in SMPS, switch mode power supplies, high speed switching, because of its low forward voltage drop. Okay, so the answer is option D. 1, 2, 3, 4. Like the video, share the video, and subscribe to the channel for better content and more videos. If you see the next question, a diode D1 under certain bias conditions has a forward voltage drop VTI 0.7 volts and IT 5.6 milliamps. So here, under same external conditions, the doping levels, the diode 2 whose doping levels are Na and Nd are both twice of D1, has the same forward voltage Vg2 0.7. Assuming the same ideality factor for both diodes, Ig2 is. So he's telling there is a diode D1. This is diode D1 whose doping levels are Na and Nd. That is P and N. And there is diode D2 whose concentrations are 2 times, that is 2Na and 2Nd. Whereas diode D1 conducts the current ID is equals to 5.6 milliamps with a voltage drop 0.7 volts. Here also D2 conducts with a voltage drop of 0.7 volts. Then what would be the current, forward diode current he is asking. Okay. Now let's see the current flowing through the diode. ID is given as I naught e to the power of forward voltage of Vd eta Vt. Vt is thermal voltage minus 1. Whereas I naught can be expanded like this. Whereas I naught is equals to AQ dp, diffusion constant of force, dp by Lp and d plus diffusion constant of electrons, effective length of electrons, and Na multiplied by Ni square. This is I naught multiplied by e to the power of Vd eta Vt minus 1. Here, if you observe, he's telling all the external parameters remain same. So if all the external parameters remain same, this is ID1 and this is ID2. In case of ID2, he's telling Nd is equals to 2 times of Nd. ID1, sorry. This is ID1, okay. In case of ID2, he's saying that AQ, dp, all these constants will remain same. Only Nd changes. In place of Nd, it is 2 Nd for ID2, second diode, plus Dn divided by Ln, 2 times of Na, Ni square, e to the power of, even forward voltage of Vd remains constant for both the diodes. This can be equal to half of ID1. Okay, this is nothing but half of ID1 if you take 2 common out. So what is ID1? 5.6 milliamps divided by 2. That is equals to 2.8 milliamps. So the answer is option B. We'll see the next question. What is the voltage across 1 ohm resistor? See, whenever a silicon diode and a germanium diode are connected parallelly, germanium diode connects first because germanium diode has low voltage drop across it, that is 0.3. That is 0.3 volts. So germanium diode connects and silicon diode remains open. So the current flows through germanium diode 5 volts, germanium diode 0.3 volts, 1 ohm. So the current I is equal to 5 minus 0.3 divided by 1 ohm, which is 4.3 amps. And what is the voltage drop across 1 ohm resistor? That is nothing but 4.3 volts. Answer is option B. Sri Raghava Academy online coaching center for the regular and backlog students dedicated to diploma and engineering courses. Semester wise and subject wise coaching is available. Contact the number 70192 46753.